Hello, Algebra 1 classes. This is going to serve two purposes, this little video that I'm making. The first is to show you, those of you who weren't in class or who want to see this again and hear it again, starting with this is how your Module 2 test fell out. I also curved it. I found the mean, the average, which was 28 average score, 28 out of 56 points. And then the standard deviation for the sample, which is both classes together, was 9. So I found the center of the grade ranges first. And then I subtracted 4.5, which is half of 9, and added 4.5, which is the other half of 9, in order to determine where my groups began. Okay? So if you got a 14.5 and up to 23, you got a D. 23.5 to 32, you got a C. 32.5 to 41, you got a B, and 41.5 and above, you got an A. So that's just a little bit, my floor, as per usual, is 55. I don't give a grade lower than that because I want you to make it up. I don't want you to give up. And like I am going to tell your parents, and like I got irritated with you guys today and I was a little harsh, I did it out of love and care. You guys are, as a group, some of you are working very hard and really trying, but too many of you are not. You are missing too many assignments. You're not trying. You're not making arrangements to come and see me during ugly hour. You are not asking any questions in class, even quietly, and it's unacceptable. You guys need to step up and take responsibility for your learning, and let's get this show on the road. So with that, we are going to begin with the basic major misconceptions that I saw on this Module 2 test, which was inequalities, expressions, and equations. So, first of all, to simplify, and I'm going to say this more than once, that's how important it is. To simplify an expression means you perform your order of operations until there is nothing left to do. Okay? There are no equal signs here. I don't want to see one on your paper when you are asked to simplify something. Here is an explanation of order of operations. I don't care if you use PEMDAS or GEMS or GEMDAS or any other mnemonic for the order in which you do math operations. Okay? You can see I drew colored circles and I used a different color for everything. They go together. They mean the same thing. Grouping symbols, parentheses, brackets, etc. They are first. So that's distributing multiplications, stuff like that. Exponents, they come second. Okay? Next is multiplication and division from left to right. And then last is addition and subtraction left to right. Okay? And here's an example. Let me move this little menu bar out of the way. Here is this expression up here after we distributed the multiplications. Many of you left this alone. You left it like this, and like this is the final answer. No. You got half credit, but you're not done. You still have some operations that you can do. You can do addition and subtraction from left to right of like terms. We're going to talk about that too. So if we add 3x and 4x because they are like, we get 7x. If we combine negative 15 with positive 20, we have positive 5. Now I can put a box around it and call it done. There is nothing else I can do to this expression. I'm not solving it for anything. I don't have two sides because there is no equal sign. I did order of operations until I couldn't do any more. To solve means to isolate the variable. Now you use your properties of equality. There are no properties of equality to use unless you have an equal sign. So here we had 3x plus 5 equals 4x minus 7. And I asked a student today, what do you want to do? You have choices. You want all of your variables on one side and all of your constants on the other. So this student said, all right, Mrs. Heinzman, I want to subtract 3x from both sides. Subtraction property of equality. Okay? Then I want to subtract 7 from both sides. I'm sorry, I want to add, I already have a subtracted 7. I want to add 7 to both sides. Okay? So the way solving an equation works is you do a little algebra and then you pause and collect like terms. You do a little bit more algebra and then you pause and collect like terms. My little bit of algebra up here was using my subtraction property of equality to subtract and thereby cancel the 3x's on this side and having them show up the negative 3x on this side. Then I paused. I combined like terms. I subtracted 3x from 4x and got a single x. Okay? Then I did a little more algebra. I added 7 to both sides. And then I paused and I combined like terms. Here we go. X equals 12. I'm done. I have a single variable and I have a constant. And if you went back into this original equation and you plugged in 12 for x, when you distributed the multiplication, 3 times 12 plus 5, it would have equaled the same thing as 48 minus 7. Okay, 4 times 12 minus 7. It would have gotten a true statement. So, once again, I want to remind you the difference between solving something and simplifying something. To solve something means you isolate the variable by using your properties of equality. You manipulate the equation to get your term that has your variable all by itself, and lastly, your variable. To simplify, you don't have an equal sign. You use your order of operations of choice, which, as I showed you in the first slide, mean the same thing. There is no difference between GEMS, GEMDOS, and PEMDOS. They mean the same thing. And you do these order of operations until you have no other operations you can do. Now let's briefly talk about combining like terms. You may combine like terms only when the terms have the same variable or no variable and power. Okay, so let's take a look at our examples. We've got 3x cubed plus 3x squared. Can I combine those? Absolutely not. They have the same variable, but the variables do not have the same power. These stand for two completely different numbers. All right? So let's get this out of the way again. So let's go to this example. 3x plus 5. Once again, cannot combine them. They are not like. One of these terms has a variable, and the other does not. These stand for two different quantities, completely different. Okay, now let's look at two green check marks, two things that you can combine. Here we have negative 3x squared plus x squared. That's going to give me negative 2x squared. Yay. And here we have 5 minus 7 equals negative 2. Once again, yay. Thank you guys for listening. I hope this was helpful. Let's do better.